Hello folks, as usual I'm going to do one round of tech check. Hopefully things are fine. Hopefully you're able to see me and hear me clearly. I seem to have forgotten my watch. I can live without that. So we have today's Pi Day, and so it's a wonderful opportunity to give me a second. I'm just seeing if the streaming ideas are sitting fine, whether we have enough people, whether the audio and video are fine, whether the bit rate is fine and all of that. Fine. So good evening to all of you. Today is Pi Day, and so Pi Day is special for a very, very narrow set of people who like ideas of pi, 22 by 7, not 22 by 7 exactly, but approximately 22 by 7, and 3.14, all of that. Fine. Why is today Pi Day? Today is the 14th of March. You really contrive it and write it as 314, then it is 3.14. Most of the world, the more reasonable people in the world write the DDMMYY format, but hey, for Pi Day there's a small exception that we can do. 3.14 is a nice approximation of pi. It had a couple of riddle and a puzzle, all of that going ahead. So I'm going to solve that or discuss that over the next maybe 5-6 minutes. Good to see all of you. Happy Pi Day. We're among, if you're watching this video, then you are as math geeky as can be. Fine. So, and we are as well, and proudly so. So we should celebrate ideas of pi. And fantastic idea and transcendental, really. Fine. So we'll start with a little bit of a joke. We don't care about your opinion. Right? So it's a riddle. Can you spot a ratio? Perimeter to radius twice. The ratio enamours math geeks, endless and elemental. Right? So obvious here that this is got to do something with pi. Right? So pi is defined as the ratio between circumference and diameter of a circle. So perimeter to radius twice. It's pi. Right? So we also reference to ratio. Obviously we're talking about pi. Right? But there's something more sitting in this, and I want you to figure out what that something more is. Right? So there's something more sitting in this. We'll take some time and figure out what that something more is. Right? There's one more question, which is beautiful, really. Right? So consider 5 points on a sphere. Prove that at least 4 of them belong to a half sphere. Right? So this question is actually solved with a beautiful idea. Absolutely, oopsie. Beautiful idea called Pigeonhole principle. Right? So beautiful principle. Those of you who are geeky and are fans of mathematics should really check this out. Pigeonhole principle is beautiful. Suppose there are 10 pigeons and 9 holes, and these pigeons go into the holes. All of them go into the holes. 10 pigeons, 9 holes. Okay? Then you can say at least one hole has more than one pigeon in it. Nice. At least one hole has more than one pigeon. It's like a bleeding, obvious, logically consistent, very simple, straightforward idea. Very powerful idea. And so, m pigeons, n holes, m greater than n. If all the pigeons go into the holes, then we can say with confidence that there is at least one hole with more than one pigeon. Brilliant. More pigeons, fewer holes. At least one hole should have more than one pigeon. That's all. Nothing more than that. Right? So these kind of questions, which seem really weird. Consider 5 points on a sphere. Prove that at least 4 of them belong to a half sphere. Right? And then I'm telling you, this is solved using Pigeonhole principle. And you're like, look, I don't get it. How can it even be? What does this got to do with Pigeonhole? Right? So it does. Fine, it does. So you have 5 points on a sphere. Many thanks to our man Abhishek and Sharan. So we have a sphere here. Right? So imagine this. You don't have to imagine this. It's pretty much a sphere. Right? So think of it like this. Oopsie. This is a sphere. There are 5 points on the sphere. Right? So imagine the 5 points somewhere here. 1, 2, 3, 4, 5. Okay? And what I'm saying, I'm locating 2 points. I'm selecting 2 points on this and drawing the great circle around that. What do I mean by the great circle? I know the center of the sphere. I locate these 2 points and I draw a circle passing through these 2 points. That will be a big circle with radius r, which is our radius of the sphere. Right? So hypothetically, we can take 2 points out of this 5, locate them in a big circle, draw that big circle, and then say, hey, at the end of this process, I have myself 2 hemispheres. The 2 points are sitting on this. I can call this, the 2 points are on this great circle. Brilliant. So out of the 5 points, I have accounted for 2. How many are remaining? 3. Right? I want to really use 3 of my fingers and point out. I can't do that now. So imagine 3 are remaining. Right? So that means the 3 points remaining have to be placed on these 2 half circles. Okay? So there are 2 half circles, 3 points. At least 1 half circle should have at least 2. Pigeonhole principle. That means either this will have 4 points or this will have 4 points. At least 4. Could have 5. I don't mind about. I don't care about that. Which goes on to prove beautifully that if there are 5 points on a sphere, there will be at least 1 hemisphere, or at least 4 of those points can be carved in one half sphere, 1 hemisphere. So if we take 2 points, create 2 hemispheres. 2 points are here, on here, and here. 3 more points remaining. 2 hemispheres, 3 points. At least 1 hemisphere should have at least 2 points. Our wonderful pigeonhole principle idea. So 3 points remaining will be 3 and 0, 1 and 2, 2 and 1, 0 and 3. That means one of the 2, the one which has larger number of points, will have at least 4. Or quite beautifully, we have proved that if we have 5 points on a sphere, there's at least, prove that at least 4 of them belong to a half sphere. And so if we want to do something with pi, pi speaks to radius, diameter, circumference, circles, round shapes, tangents, chords, and spheres. You think of pi, you think of all of these shapes in some form, circles mostly. So we thought we wanted to do one question, which is unusual, not directly linked to exams that we're preparing for, but can put a smile on people's faces. It does put smile on people's faces, people who are automatically happy when they see pi somewhere. Right? Anyway, let's go back to this question that we have. Can you spot a ratio, perimeter to radius twice? Right? The ratio enamours, math geeks, endless and elemental. Right? So this is linked to pi, the ratio is pi, perimeter to twice radius twice is pi. What is special about this is 3 letters here, 1 here, 4 here, 1 here, 5 here, 9 here, 2 here, 6 here, 5. So 3.1415926535897 Those are the first few digits of pi. And so it is said that there are limericks and stories in ancient text, frequently Indian text, that allude to the digits in pi, that reference digits in pi. This is a stab at this. And so, like all of us have heard of all silver teacups as a mnemonic to remember all sine, tangent, and cosine for quadrants and positive and all of that. Hey, maybe if you're taught this, then we can remember that 3.141592653578979. Right? So why would anyone want to remember the first 14 digits in pi? Such a silly question. How can anyone not want to remember the first few digits of pi? Right? So with that, I'm going to stop today. Good to catch up with all of you. Hopefully, you'll continue to retain your fascination for pi and all things mathematical. Look forward to seeing you in more sessions. We are hoping that you are enamored by ideas like this. Right? Best wishes for Ken.